Hello, grade 6. Welcome back to Nelson Math, chapter 14, section 2, performing and measuring rotations. I have a sample here of a pendulum. So it swings left and right, as you see here. It starts here and then swings over, goes here, and then just swings back and forth. If I wanted to measure this angle, we have to go by the procedures that I told you on a previous day. One of those procedures was this point, this vertex, must be in this little white dot over here. So let's see if we can do that. So I've met two of my criteria here. You can see that I have my vertex on the white dot. I have one arm on this line right here, which is where one arm has to be. However, I have a problem here, and that is I can't measure an angle with my protractor in this direction because the angle is opening up this way. So I have to find a new way to orient my protractor. And as you can see now, even though my protractor is somewhat upside down on the side here, it's fine because I have met my criteria of my point being right in this white opening in the protractor. One arm is at the 0, which is right there, and the other arm is right here, which is pointing to a number in my protractor. It's pointing at two different numbers. Might be hard to tell, so I'll read it out to you. It's pointing at the 55 if I use this scale, and pointing at the 125 if I use this scale. However, they can't both be right. And in this case, because our 0 is starting here on the outer scale, we are going to call this angle 55 and the 55 degrees. So the correct measurement for this angle is 55 degrees. It would be 55 degrees any which way we held our protractor. I just spun my protractor around so that still I have my vertex where the two lines meet. I have them in that white dot. I have this arm of my angle at the 0. And now we're going to use the scale that starts on the inside. So 0, 10, 20, 30, 40, 50, 55. The angle is still 55 degrees, any which way you measure it. This is one of your homework questions from the checking from your textbook. And the question asks, Mark rotated the faded shape to its new position. So where it's faded, this is where it was. It started here. This, the darker shape, is where it finished. It ended here. Which point is the center of rotation? The only point this could be the center of rotation of, well, of course, it could be any one of these 4 points, but only one of them is correct. Because it started here and it moved over to here, it rotated over to here, whatever the point of rotation was did not move. The point of rotation stayed exactly where it was. So we could do a process of elimination, or we could use a little bit of logic. So let's take, for example, the circle right here. And if we look to the side of the circle, this point that I'm highlighting right now, right there, is the same as this point right here. There's only one point that's 4 units from the x. 1, 2, 3, 4. And there's also 4 units of the x from here. 1, 2, 3, 4. So the only point of rotation for this must be the x. This is the only point that would be the same distance for anywhere on this figure, this yellow figure with the white circle in it. The only shape, the only point around the rotation is just this one. None of the other ones would work. For example, if we took y, if we look at this point right here, right in the middle of the bottom of the faded shape, if this point rotated, it would have to be right there, but it's not. It's right there. So it's not y either. It can't be z because z lies on the shape. So if it's on the figure and the new figure is now over here, no part of the figure is on the z. So it cannot be the z. And the w, it's the same thing. It's way out there. So if we rotate it about here, then the shape would end up being up here above this one. So it's clearly not that one. So X is the center of rotation. Describe the rotation by naming the angle, direction, and the center. The angle is a 90 because as long as we take the same part of both shapes, whether it's this, we must take the start and the end. We can take this line right here, this vertical line right here that I'm highlighting. This line ended up down here. So the angle that's formed is a 90-degree angle. I just labeled the same side of both shapes with this solid black line. So whatever this line forms is what that shape is, what that rotation is. And the angle is 90 degrees. The direction, we started from here and we went here. We're going counterclockwise. We're going backwards from what a clock does. And the center of rotation is the X. 3C, draw the new location of the shape if it is rotated again around the same center in the same direction with the same angle of rotation. I've just made the rotation from this shape over to this shape. And you can see that the figure is exactly the same. I haven't changed the figure, but what I did do is I rotated it. So I rotated it 90 degrees counterclockwise, and the center of rotation is still the X. I know the center of rotation is still the X because let's, for example, take this point right here, which is on the line. It rotated down here to this point right down there. So all of that, after doing the 90-degree counterclockwise around point X, that's where it ended up. Thanks, everyone, and have a good day.